think is the strongest muscle in your body? If you've guessed the masseter, you're right. One of the main muscles that help you to chew food, this can generate over 200 pounds of pressure when you clench your teeth together. It would obviously be enough to break your jaw, so the motion of chewing is more refined than that. In this session, we're going to look at the muscles of mastication in more detail. First, we'll look at the role and purpose of mastication, and then review the anatomical structures, such as the skull, joints, and muscles. We'll see how the muscles pull the jaw in different directions. All muscles are controlled by the brain, so we'll go through the neurological pathways involved and the cranial nerves that send signals to and from structures in the jaw. Before we start, make sure you have the mastication handout in front of you. We'll pause at times so you can take notes to keep track of what you're learning. Let's begin. The first role of mastication is to help us bite off small pieces of food into manageable chunks. We then grind the food down using the teeth and jaw and mix it with our saliva to make a smooth paste. This is easier and safer to swallow than a huge chunk of food, so it reduces the risk of us choking. To understand the mechanism of mastication, we need to have a good understanding of the machinery involved, which is all found around the jaw and skull. Let's start by looking at the jawbone, known as the mandible, in isolation. If we spin this bone around to look at it from the lateral side, you'll see that it has an angle, which is called the ramus. There are two processes at the top called the condylar process and the coronoid process. If we turn the mandible to look at it from the inside, we can see the medial surface of the ramus. Different muscles attach to the lateral and medial sides of the ramus, so remember this. Now let's look at the skull, which is a jigsaw puzzle of different pieces. You can see the mandible here. The mandible fits neatly into the skull on the temporal bone. This forms the temporomandibular joint, in which the condylar process of the mandible glides along a curved recess in the temporal bone. Going back to the skull, we have the zygomatic arch, or your cheekbone, highlighted in yellow. The maxilla is the main bone in your face, shown in blue. Now let's spin the skull to look at it from underneath. At the base of the skull, we have the sphenoid bone in green. The palatine bone is highlighted in pink, and the maxilla is shown in blue. Remember these so you know which bones the muscles of mastication attach to. The last important bones involved in chewing are, of course, the teeth. You have 4 sharp incisors for biting on the top and bottom respectively. You have 2 canines for tearing bread or meat on the top and bottom. 8 premolars sit behind the canines, and finally there are 12 flat molar teeth which do most of the grinding down of the food. The top teeth slot into the maxilla bone and the bottom teeth slot into the mandible. Now we know the bones, let's look at the muscles. The largest muscle is the temporalis, which is fan-shaped and attached to the temporal bone, hence its name. The other side of the muscle attaches to the coronoid process of the mandible. When the muscle contracts and shortens, it retracts and elevates the jaw to close the mouth. Next is the powerful masseter. We're glad you're enjoying Swallow Hub videos. We've got something even better for you. A dysphagia resource guide available as a digital download. You'll receive the full version of this video, as well as a PDF document full of easy to understand explanations, beautiful anatomical diagrams, clearly explained neurology, and cranial nerves made simple. You'll even have access to a printable worksheet to take notes through the video, and there'll be a completed worksheet for quick reference in future. Interested? Click the link in the description below. Here's some more information if you want to find out more.